Right, so on Friday, we started talking about the actual sum of a sequence. And as you know, there are two specific types of sequences that we're looking at, arithmetic and geometric. So first of all, let's look at arithmetic, because we don't physically want to write out each particular term and then add them up. I mean, that's just too time consuming, well, depending on how many terms we have. So let's create a formula. The sum to all the terms, so the first term is A, plus the second term, A plus D. Third term, A plus 2D, all the way, and then we'll a last term somewhere. So let's just call it L for the last term. And the term before that would be L minus D. And the term before that would be L minus 2D, and so on. In fact, that's so good, I'm going to write it again, but backwards. Okay? Now I've created some simultaneous equations, but you'll notice the way I've written it is the plus D on the top line lines up with a minus D on the bottom line, and the plus D on the 2D and the minus 2D and so on. So if we add these two equations together, I'll get two lots of the sum is A plus L, oh, the D's disappear, A plus L, oh, two D's disappear. And all the way along I'm going to get all these A plus L's. Question is, how many groups of A plus L's do we have? Well, N. Because each one of those pairings matches up with a particular term. And we know there are N terms in our sum. So we know that's N lots of A plus L. Well, divide by 2, and I've got a neat little formula. So if I know what the last term is, I can say, well, I know the sum of this series. It's going to be the first term plus the last term multiplied by N on 2. Logically, why? What does that formula do? Have a think about it. Anyone think what that formula is actually doing? What it's doing is it's getting the first term and the last term and finding the average. And it's turning every pairing into the average. And we're assuming every term then is the average of the first term and the last term. See? So you got, if I had rewritten it a different way, I'd go, well, A plus L over 2, which would be the average of the first term and the last term. So what we're actually doing in this formula is we're saying, what's the average of the first and the last term? And we're going to assume every term is the average, so we multiply it by N, and that gives us the sum. So that's what this formula actually does. Well, if we don't know the last term, what we do is substitute in the general term for the last term. And the general term, remember, was A plus N minus 1D. Tidying up there, because now I've got two A's, and that's where the other formula comes from you might have seen before. There's still the N on 2 out the front, but then it's 2A plus N minus 1D. So if I don't know what the last term is, I'll use that formula. So any of the questions really, it involves what data do we know? So we read through the question and try to extract as much data as I can. Once I know what I've got, then I just substitute it into a relevant formula and come up with an answer. So I know the first term is 3. I know the sixth term, or the last term in this case, is 96. Find the sum of those 6 terms. Okay, well, I know the first term, I know the last term. So subbing in, and there's 6 terms all up. So 3 lots of 3 plus 96, 297. Find the sum of the first 100 even numbers. And let's pretend for some insane reason I don't actually know what the 100th even number is. Ooh, too hard to work out. Ooh, wonder what it would be. Okay? So in this case, I'm going to say, well, look, I know the first term is 2. The common difference would also be 2, because it's going up by 2s. And I know there's 100 of them. Oh, I know A, I know D, I know N. I can use the other formula, N on 2, 2A plus N minus 1D. Substitute into that. And eventually, a little bit of maths, of course, there it is, 10,100. The sum of the first 10 numbers is 100. And the sum of the first 5 numbers is 25. We've got to work out what the first term is, the general difference, and, the common difference, and the general term. So what do we know? I know the sum of 10 terms is 100. So 10 on 2, n on 2, 2a plus n minus 1, in this case that's 9. 9d is 100. I might just tidy that little formula up. We get 2a plus 9d is 20. The other piece of information they've given me, the sum of the first 5 terms is 25. So 5 on 2, 2a plus 4d, n minus 1 is 4, is 25. Tidying that one up, I get a plus 2d is 5. I got 2 equations, 2 pronumerals, must be possible to solve them simultaneously. So let's do that. I'll change the second one. I'll multiply everything by 2 and I'll get 2a plus 4d is 10. Now we can eliminate the a's. 5d is 10. So our common difference is 2. Subbing back in, we get then that the first term is 1. Now let's come up with a formula. Term n is a plus n minus 1d. So 1 plus n minus 1 times 2. Tidying that, I get the general term 2n minus 1. So I'll just write a final statement there. A is 1, d is 2, term n is 2n minus 1. Get in the habit of writing a final statement to your problem. Okay? It's so much easier when people are looking at your solution to just go, bang, there it is. Okay, we know what you're, rather than having to search through all your working and go, where's the answer for this bit? Where's the answer for this bit? Where's the answer for this bit? Okay? So it's just a way of communicating your solution. All right, sigma notation. Sigma notation. So sum of, there's the general formula, 3n minus 6. We're going from the first term to the 10th term. So I'm going to use the a plus L formula. So the first term is negative 3 when I substitute 1 into the formula. The last term will be 24, and we've got 10 terms all up. So n on 2, a plus L, and there it is, 105. 105 for that one. Oh, but like I said the other day, be careful with the sigma notation. If they're not starting with 1, then the first term actually will be n equals whatever they're starting with. It's not necessarily always going to be 1 when they use the sigma notation. And when you're working out the number of terms, the common mistake people do is to go, oh, 10 minus 1 is 9. But remember, it's inclusive, so you've got to add 1 back on. So there's 10 terms with that. Okay, let's have a go at 6i.